Having a well-designed system means that it needs to be well organized. We've seen how this can be achieved with a variety of design principles. One thing we have yet to explore is how to address information access. You do not need everything in your system to know about everything else. The module should only have access to the information that it needs to do its job. So, how do we limit the amount of information our various modules of our system can have access to? We do this by applying information hiding. Information hiding allows modules of our system to give others the minimum amount of information needed to use them correctly, and hide everything else. Information hiding allows a developer to work on a module separately, without other developers needing to know the implementation details of this module. They can only use this module through its interface. In general, things that might change, like implementation details, should be hidden, and things that should not change, like assumptions, are revealed through interfaces. Let's say we were both working on the same system, but on different modules. If my module requires information from your module, information hiding allows you to provide me with just the information I need for my module to work. You do not have to give me access to everything in your module, and you don't need to know how my module works. Information hiding is often associated with encapsulation. We use encapsulation to bundle attributes and behaviors into their appropriate class and expose an interface to provide access. Encapsulation effectively hides the implementation of behaviors, since the only access is through an interface of specific methods. Other classes can only rely on the information in these method signatures, not the underlying implementations. Information hiding through encapsulation allows us to change the implementation without changing the expected outcome. We can still fulfill the expectations for a behavior without exposing how we get there. Take a look at this example. The string library has a method called concat, but how is it implemented? Are there extra data structures being used, or other method calls being made that we do not have access to? As a user of the library, you are given access to the concatenation functionality through an interface, a particular method signature, but you are not shown how the functionality is implemented. That is because the implementation may change, and you should not depend on how it actually works. The interface establishes the only assumptions you can rely on. Attributes can also be hidden in order to prevent critical information of a class from being changed directly. For example, if an attribute is critical to all the behaviors of a class, then we do not want any external classes changing it directly. You can apply information hiding to your own classes in your system. It will allow you to hide information that you need but do not want to show to others. Encapsulation is the practical design principle used to apply the concept of information hiding. You can hide information through the use of access modifiers. You probably have experience using them. Access modifiers change which classes are able to access attributes and behaviors. They also determine which attributes and behaviors a superclass will share with its subclasses. There are 4 different levels of access in Java: public, protected, default, and private. Attributes with a public access modifier are accessible by any class in your system. This means that other classes can retrieve and modify the attribute. Public methods are also accessible by any class in your system, but this access does not allow other classes to change the implementation of the behavior for the method. A publicly accessible method simply allows other classes to call the method and receive any output from it. In this example, the person class has a public attribute, which anyone can access and have modified to be John Doe. The person class also has a publicly accessible method named sleep. Notice that we can invoke the behavior, but we cannot change how it is implemented, because it is hidden from us through encapsulation. Protected behaviors and attributes are not accessible to every class in the system. They are only available to the encapsulating class itself, all subclasses, and classes within the same package. Packages are the means by which Java organizes related classes into a single namespace. Let's take a look at another example to see what this means. We have put the person class in a package called Populace, which contains all classes related to the people of a country. Notice that the person's name attribute is protected. The university class is in a new package called Educational Institution. This package imports everything in the Populace package, which will give us access to the publicly accessible person class. If you look at the main method, you'll notice the emphasized line of code. This is to bring your attention that this line of code does not work. We cannot access the name attribute from the person class because it is protected and it is in a different package. This access modifier also applies to methods in classes. The default access modifier will only allow access to attributes and methods to subclasses or classes that are part of the same package or encapsulation. This access modifier is also called the no modifier access because you do not need to explicitly declare it. See how we haven't declared any access modifier for name attribute? This will set the access to default access and apply the default access level. The last access modifier is called private. Private attributes and methods are not accessible by any class other than by the encapsulating class itself. This means these attributes cannot be accessed directly, and these methods cannot be invoked by any other classes. Information hiding is a powerful idea. You control what information you want to share and what behaviors you want to let others see. You reveal assumptions through interfaces that others can rely on, and hide changeable things like implementation details. Information hiding allows you to build flexible, reusable, and maintainable systems.